Welcome to Introduction to Data Structure and Algorithm in 10 minutes. In this video, we will explore the fundamental concepts of data structures and algorithms, providing you with a strong foundation to excel in computer science and programming. Array. What is an array? Okay, so let's start with the basics. An array is a data structure that allows us to store multiple elements of the same type in contiguous memory locations. It provides easy access to individual elements through their indices. Here are some benefits of arrays. Arrays offer several advantages, such as constant time random access to elements, efficient memory utilization, and straightforward implementation. They are commonly used to store and manipulate collections of data. For example, if we want to store the names of 100 people, then we can create an array of the string type that can store 100 names. String array equals new string 100 in Java. Linked list. What is a linked list? Moving on, a linked list is a linear data structure that consists of nodes linked together via pointers. Unlike arrays, linked lists can dynamically grow and shrink, making them more flexible. Types of linked lists. There are different types of linked lists, including singly linked lists, doubly linked lists, and circular linked lists. Each variation offers its own set of advantages depending on the use case. For example, we can access the previous and next URL searched in a web browser by pressing the back and next buttons since they are linked as a linked list. Stack. What is a stack? Let's explore the stack data structure. A stack follows the last in first out, LIFO, principle, meaning that the last element added is the first one to be removed. It operates on the principle of adding elements to the top and removing elements from the top. Common stack operations. Stacks support three primary operations: push, to add an element; pop, to remove the top element; and peek, to view the top element without removing it. They are frequently used in applications like expression evaluation and backtracking. For example, plates stacked over one another in the canteen. The plate which is at the top is the first one to be removed, i.e., the plate which has been placed at the bottommost position remains in the stack for the longest period of time. Queue. What is a queue? Moving on to queues. A queue is a data structure that follows the first in first out, FIFO, principle, meaning that the element added first is the first one to be removed. It operates on the principle of adding elements at the rear and removing elements from the front. Common queue. Queues support three primary operations: int to add an element to the rear, the queue to remove the element from the front, and peek, to view the front element without removing it. They are widely used in scenarios like task scheduling and breadth-first search. For example, waiting for the bus, waiting in front of the elevator or a vending machine, all share one quality: the person standing in the front goes before one standing behind. Binary tree. What is a binary tree? Let's explore a fundamental type of tree structure known as a binary tree. A binary tree is a hierarchical data structure comprising nodes, where each node has at most two child nodes. The left child represents the smaller element, while the right child represents the larger element. Binary tree traversal. There are three common ways to traverse a binary tree: in order, left root right, pre-order, root left right, and post-order, left right root. Each traversal method provides a different order of accessing the tree nodes. For example, we have head node A. Left child is B and right child is C. Here we will traverse according to the order given to us. Binary search tree. What is a binary search tree? A binary search tree is a variant of a binary tree that adheres to a specific ordering property. In a binary search tree, the left child of a node is always smaller, and the right child is always larger. This property enables efficient searching, insertion, and deletion operations. Operations on binary search trees. Binary search trees support various operations, including searching for an element, inserting a new element, and deleting an element. The tree's ordering property significantly aids in achieving efficient search times. Heap. What is a heap? Moving on, a heap is a specialized tree-based data structure that satisfies the heap property. A heap can be visualized as a binary tree that can be implemented using an array. Heaps are commonly used to efficiently retrieve the minimum or maximum element. Types of heaps. Two types of heaps are commonly used: min heap, where the smallest element is at the root, and max heap, where the largest element is at the root. They enable efficient priority queue operations and are critical in sorting algorithms like Heap Sort. For example, heap sorting can be applied to a SIM card store where there are many customers in line. The customers who have to pay bills can be dealt with first because their work will take less time. This method will save time for many customers in line and avoid unnecessary waiting. Hashing. What is hashing? Hashing is a technique used to map data to a fixed size array, known as a hash table. It provides fast and efficient data retrieval by transforming the data into a unique hash value, which acts as an index to store or retrieve the data. Collision resolution. Collisions can occur when two different inputs produce the same hash value. Various collision resolution techniques, such as chaining and open addressing, are used to handle such scenarios and maintain the integrity of the hash table. Assume a scenario where we intend to store the following set of numbers equals 0, 1, 2, 4, 5, 7 into a hash table of size 5 with the help of the following hash function h, such that hx equals x%5. In this case we see a collision of two terms, 0 and 5. In this situation we move linearly down the table to find the first empty slot. Graph. What is a graph? Let's dive into graph data structures. A graph is a collection of nodes, also known as vertices, connected by edges. It is a versatile and powerful data structure used to represent relationships between objects. Types of graphs. Graphs can be categorized as directed or undirected, weighted or unweighted, and cyclic or acyclic. Each type of graph has its own characteristics and applications in various domains, including social networks and routing algorithms. For example, in Facebook, each person is represented with a vertex or node. Matrix. What is a matrix? Another important data structure is a matrix, which is essentially a two-dimensional array. It provides a convenient way to represent tabular data and facilitate efficient operations like matrix multiplication and manipulation. Matrix operations. Matrices support various operations, such as addition, subtraction, scalar multiplication, and matrix transposition. They are extensively used in linear algebra, image processing, and scientific computation. Matrices are used to represent linear equations and to solve systems of linear equations. Optimization. Matrices are used in optimization problems, such as linear programming, to represent the constraints and objective functions of the problem. Miscellaneous data structures. Apart from the aforementioned data structures, there are several other miscellaneous data structures like sets, trees, dictionaries, and graphs. Each has its own unique characteristics and applications, catering to specific problem domains. Advanced Ds. Exploring advanced Ds. This video serves as an introduction to data structures and algorithms, covering the essential concepts that form the building blocks of computer science. For further exploration, there are numerous advanced data structures available, such as red-black trees, aviar trees, tries, and more. Congratulations! You have now been introduced to the fundamental data structures and algorithms. Armed with this knowledge, you are ready to tackle more complex programming challenges with confidence. Keep exploring and happy coding!